right, this is our first lesson from the first unit, and our first unit comes from a group of ideas that come out of various parts of our book. This first one is out of chapter 4 from your book, and then we're going to start by just talking about some basic sets of numbers for where these would apply most specifically. This is no longer page 93 in your book, this is page 83, so there is a chart in there on page 83 that you can refer to for some good reminders on these, as well as some symbols and things like that. So let me just go through some of these basic things. As you look over here at the target with the way I drew it, what I'm intending for you to see is that these are the most specific numbers right here, the natural numbers. This is the smallest group, and then as you branch out, so the next one would be integers. Notice that the integers also include the natural numbers. Just like the rational numbers that you see here would also include integers and natural numbers. They just take the set that you already have and they expand on that. So for example, with the natural numbers, the most specific group, we have 0, 1, 2, 3, 4, and onward. No negatives, no decimals, no fractions. It does include 0, so do keep that in mind. That's something that often comes up and people forget. But it just goes in towards the positive direction from 0. And as you branch out from there, as we get into integers, integers include all those same numbers that we just mentioned, but now they also add in the negative numbers. And so now you would have not only the 0, 1, 2, 3, 4, and so on, but now you can include the negatives as well. So -1, -2. And as you expand out from there, again, if this is my group of rational numbers, again, keep in mind that the rational numbers include all of what we've talked about so far, but they now add in the fractions as well. So one way to define rational numbers is any number that can be written as a fraction. So even if I had something like 0.2, well, 0.2 can be written as a fraction. We know that's 2/10 or 1/5, either way you want to look at it. But any number that can be written as a fraction is considered rational. Even when you look at a number like 3, 3 could be written as a fraction. If we wrote that as 3/1, we still see that as a fraction. Even if I wrote it as 6/2, it's still considered, you know, even before it's reduced, you still would look at that in its most simplified form before classifying it. So again, anything that can be written as a fraction would then fall under the rational category. When you move beyond the rational numbers, anything that could be written as a fraction, when you move beyond that, everything else falls under the real category. In the past, you have seen an irrational category. IB does not use an irrational category. They simply place everything that's not rational under the real umbrella that you see here. So those would be anything that can't be written as a fraction, such as pi, the square root of 3, any number that is an ongoing decimal and does not have any pattern to it. So if you did have something like, let's just say 0.111111, right? 0.1 repeating forever, even though it goes on forever, it has a pattern to it, and therefore it could be written as a fraction, and that makes it rational. So irrational, again, is what we just put under the real umbrella, and it's anything that cannot be written as a fraction. They are ongoing decimals that have no pattern to them. Typically what you're going to be asked to do with these is to identify the most specific category that they fall under. So for example, if I gave you a number like 2, even though 2 is an integer, right, we would still place it under the most specific category that we can. And so you're always trying to work your way in to the center of this bullseye as far as you can go. So on a test, when they ask you to classify a value, you always want to give it the most specific category that it falls under. So even though 2 is an integer, if we labeled it as an integer, we'd get it wrong because we could have been more specific and put it under the natural category. So again, you always want to be as specific as you can with those. Just a quick side note, and you'll see this in the book if you take a look at page 83. But one of the other ways they might name something is they might put like a little plus sign right here and call this Z plus. That would be referring to the positive integers that could be listed. So positive integers would then just be 1, 2, 3, 4, and so on. So it would not include 0, things like that. So you do see a little bit of those little types of changes within the signs, but you really need to know not only the names and what these numbers fall under, but you also really need to know the symbols, because oftentimes on a test they don't use the words, they use the symbols, and so you really need to know what those symbols are referring to. And so really important that you remember what symbols go with which vocab words. Those should be easy points, so those are just things you need to be familiar with. Moving on down into significant figures, this is something that you likely have run into already within a science class that you've taken. So just to go over some basics with sig figs, this is a major idea that will play out through the entire year. At the beginning of every test that you see, especially the IB test, for those of you taking the IB test this year, the directions are going to say, write all of your answers in exact form or round it to 3 sig figs unless the directions say otherwise. And so that's always the general standardized testing directions that you're going to be given for every test that I give you. And again, that's to write your answer in exact form or 3 sig figs unless the directions say otherwise. And I'll show you a few of those examples here in a second, but let's just talk about what qualifies as a significant figure. When you're dealing with things to the left side of the decimal, trailing zeros do not count. And so what you see underlined here, that 5 is the only significant figure, so this would be a number like 500 would only have 1 sig fig within it. If you have a 0 that is trapped between other sig figs, it does count, but again, trailing zeros do not count when you're on the left side of the decimal. And so this 0 would not count, so we would have the 3, the O, and the 6. Those would be our 3 sig figs for this problem. On the right side of the decimal point, again, any number that is trapped between other sig figs always counts. So this would be another case for 3 sig figs. When you're on the right side of the decimal, initial zeros do not count. And so we would see this as rounded to 1 sig fig. Trailing zeros do count when you're on the right side of the decimal. So in this case, the initial zeros do not, but this ending 0 that we have here on the right would count. And so within these examples, I've given you every scenario that you could run into. And so this would be a pretty good model that you can follow for any case that you run into down the road. Again, anything that basically hugs the decimal point, those zeros don't count. So if it's to the right of the decimal point, those zeros, the initial zeros would not count. If it's on the left side of the decimal point, again, you would have a decimal point technically right here if this were 500. So because these are attached to the decimal point, they don't count. So we count the things that are away from those zeros. So again, as we get to this final part here on the first lesson, as I mentioned, on test directions, you're going to be asked to leave answers in exact form. So if you look at this problem right here, this says find the area of a rectangle. Here's the width, here's the length. Obviously, I'm just going to multiply width times length to get the area of this rectangle. So here's a couple ways that you could write your answer. This would be exact. So if I just did 72 times 86, this is the exact value that I would see for the area of this triangle. And so on a test, if the directions just say exact or 3 sig figs, this would be an accepted answer. So this is the exact form. If it said, if you wanted to round this to 3 sig figs, then we would write this as 6190, and that would count as 3 sig figs. And remember, those are always your standard way of writing your answer unless the directions say otherwise. And this is one of those things that the directions could say that would imply some other version of your answer. So in this case, when they say an appropriate level of accuracy, all that's referring to is the amount of sig figs that were used within the problem. So if you look here, we have, for this width, I have 2 sig figs. My length has 2 sig figs, which means the appropriate level of accuracy for my answer would also be 2 sig figs. And so with this phrase that I see right here, I'm going to stick with that, and this would be the answer written to 2 sig figs. And so that would be the correct way to write your answer for this problem, simply because this phrase was given within the problem. And so I got to stick with that. If this phrase were not here, then I could have done either the exact answer or I could have rounded this to 3 sig figs. Right down here we have the area of a circle, which remember that formula is pi r squared. You will have a formula packet that you get to use on every test, and we will talk about that in class. You really don't have a whole lot of formulas to memorize this year. All the necessary formulas are within your formula packet, including the area of a circle. So we got pi r squared. So here's the radius of 2.33 centimeters. And again, you can either do exact or 3 sig figs unless the directions say otherwise. If you were to put this into a calculator, you're going to get an ongoing decimal. There's no way to write this in exact form. Oftentimes people look at their calculator screen and they say, well, if I just write down every number that I see on my calculator, then it's exact. Well, that's not necessarily true. Your numbers can't contain the values of this number. They go on forever. So you do have to round it. So the question is what should I round it to? And again, you would always round to 3 sig figs unless the directions say otherwise. And in this case, if my directions say an appropriate level of accuracy, that means I got to use the sig figs that are used within the problem. And so in this case, I have 3 sig figs that are used within the problem. Therefore, I'm going to round my answer to 3 sig figs. And so that's what that should look like. You do need to include units. For those of you taking the IB test, they mark you off for not using the units. So it's really important that you get in the habit of including units. And that's pretty much it for this. My one last side note that I would say is, even on the really simple problems, show your work. You always want to show the setup of the problem. There's always room for partial points, just in case you happen to get an answer wrong, especially for those of you taking the IB test. There are certain problems where you can only get all the points if you show the work and the correct answer. So it's really important that you're in the habit of showing the setup that you're used to get your answer. Even if you think it's one of the really easy problems, show your work anyway.